Okay, so today we're going to start with our molecular/covalent compounds. So put both words on your notes so we know we can use those words interchangeably. And then just a reminder, you only need to write down the bolded words. Okay. So molecular compounds, they're going to be made up of a nonmetal bonded to another nonmetal. Okay, so all nonmetals. And if we review from last class, when we look at the periodic table, how do we know if something's going to be a metal? Okay, in the middle, so everyone look at the paper periodic table. Look at the one that you get to use on a test. Do you see that bold staircase on the right side? Okay, if it's to the right of the bold staircase, it's a nonmetal. If it's to the left of the staircase, it's a metal. With what one exception? Hydrogen, it's top left, but it is a nonmetal. Okay. So that's how you're going to know. You just look at that bold staircase. So some examples of molecular compounds is just water, H2O. So if you look at the periodic table, are both hydrogen and oxygen nonmetals? Good. Okay. Another example is carbon dioxide. Again, if you look at C and O, are they both in the nonmetal section? Good. Okay, and then these ones have the properties of the low melting point and low boiling point. So today, the covalent compounds are the ones that actually melted, right? So if they have a low melting point, they melt first. They're poor conductors of electricity. So when you put the voltmeter in, they're the ones with the dim light. They don't typically dissolve in water. Sugar is a complicated exception. Sugar breaks apart from like a clump of molecules, but the individual molecule doesn't break apart. So technically it doesn't dissolve, but to your eyes, does it look like it dissolves? Okay, so that one's kind of the tricky one. They do dissolve in alcohol. And then most are gases or liquids at room temperature. Okay, so today I had to find some examples that were solids, but like water, what's water normally at room temp? Liquid. What about carbon dioxide? What's carbon dioxide? Gas. Okay. So most liquids and gases, but there's exceptions, right? Like acetaminophen is Tylenol, which is a solid. Okay. Our other type of compound, they're called ionic compounds. What word do you see in ionic? Good. Ion. Okay. So ionic compounds are formed when ions join together. And specifically, one cation bonds to one anion. What kind of a charge does a cation have? Okay, positive. What charge does an anion have? Negative. Okay, what do we know about positive and negative charges? Opposite charges.
Oh, they attract.
They attract. Okay. So this is why ionic compounds form, right? The cation is attracted to the anion. They want to bond. They want to make a compound. So usually, this means that you're going to have a metal bonding to a nonmetal. There are exceptions. Okay. You can have cations that aren't metals. So as long as you have a cation bonding to an anion, it's ionic. Okay. But like 99% of the time in this class, it'll be a metal plus a nonmetal. So going back to your periodic table, how do you know if something's a metal? Okay, what side of the staircase is it on? Okay, left side, and then your nonmetal is right side. Okay, so even though ions have charges, when they bond and they make an ionic compound, they are going to be electrically neutral. Highlight that, star it, underline it. Okay. So, for example, sodium chloride is just table salt. Sodium gets a +1 charge. Chlorine gets a -1 charge. What do those charges do? They're going to cancel out, which makes sense. When you touch table salt, do you get like electrically shocked? No, because it's not charged. So they are neutral. However many plus charges you have, they cancel out with the number of negative charges. So as we learn how to write formulas, you'll notice that when we write formulas, there's no charges because overall it's not charged. And then properties of ionic compounds. These ones have high melting points and boiling points. So these are the ones that didn't melt. Because they're ions, they are good conductors of electricity. They do dissolve in water. They don't dissolve in alcohol. And most of these are going to be solids at room temperature. Okay, so now the goal of the day is if we look at a formula, we want to be able to classify it as ionic or covalent. Okay, so first we just have to look at chemical formulas. So formulas, they just show you the kinds of atoms or the kinds of elements and the numbers of atoms in that compound. Okay, so like here's just an example. We have Ca3OH, or this is called calcium hydroxide. So when you look at a formula, how can you distinguish the different elements? Good. When you look at a formula, how can you distinguish the different elements, like in this formula?
Oh, the number.
And the capital letters. Right. Okay, so one capital letter, so what element is this? What's Ca? Calcium. Okay, then a new capital letter, so a new element. So what element is O?
Oxygen.
Oxygen. And then a new capital letter, so what element is H?
Hydrogen.
Okay, so when we look at formulas on the next slide, we're just looking for those capital letters. Sound good? Okay, so now here's the big goal of the day. If you look at a formula, you need to classify it as ionic or molecular. And today I gave you simple ones, just 2 compounds. So one capital letter, that's your first element. Second capital letter is your second element. Okay. So now you just figure out if they're metals or nonmetals. So if you look back at your notes, if it's molecular, what's going to be in the compound?
Non-metals.
Okay, 2 nonmetals. If it's ionic, what is it going to be?
Metal and non-metal.
Okay, metal and a nonmetal. So this is where you're going to use your periodic table. Okay, so the first one's potassium. So look at potassium. Is it a metal or a nonmetal?
That's a metal.
Okay, and then you look up the chlorine. What's chlorine going to be? Okay, so metal plus nonmetal is going to be the other one. So metal plus nonmetal is going to be ionic. Okay, our next one is CO. So our first element is C. Our second element is O. Metal, nonmetal. What's carbon?
Non-metal.
Okay, nonmetal. What's oxygen? Okay, what are 2 nonmetals? Okay, molecular. If you're writing covalent, is that also fine? Okay. Okay, next one is strontium selenide. So your first element is Sr. Your second element is Se. So Sr, metal or nonmetal?
Metal.
Metal. Okay. Notice Sr is number 38. So is it definitely to the left of that bolded staircase? Okay. What is Se?
Non-metal.
Nonmetal. So what do we call it if it's metal plus nonmetal? Okay. You want to try one on your own? Are we ready to try one on our own? Okay, you try BaO is barium oxide. Okay, what's barium? Metal or non-metal?
Metal.
Okay, metal. What's oxide? Non-metal. So how did you classify it? Okay, give me like a thumbs up. You're feeling good. You're getting the pattern. A thumbs down is like, no, Mrs. Wilcox, no. Thumbs in the middle is like, maybe. Okay, can you try the last 4 on your own, then we'll check. Okay, what did you call calcium chloride? What about sulfur trioxide, or SO3? Okay, molecular. What about CCl4? And what about MgF2?